All right, so I would like to quickly record a video about a query optimization because it is rather interesting to see those like tricks that can be applied, and it's also quite an interesting query. So let's dive right into that. I came from looking at a checkup report that we get from the production database once a week. And it basically looks at 30 minutes interval and records all the queries that come in. And one query stood out, or actually quite a few are interesting, but that's the one I took. And this is this one. You can see that it's not called very often, so the frequency is not as high as for other queries, for example. But the average query timing is quite concerning. So that is at about 8 seconds per call, and we saw this 360 times in about 30 minutes. And I took that query. When you format that a little bit, you can see that better. So it is actually fairly standard query. We like to retrieve projects for a particular user. That's my user ID in this case. And we like to retrieve the private ones, or the ones that are like that I'm authorized to see. And in addition to that, the ones that are internal or public. So basically, when you're at GitLab.com, those are quite a lot of projects because we have a lot of public projects. The way we do that is we basically OR those two conditions. Additionally, we're looking at, or we want to exclude the projects that are pending deletion. And the caveat here is that we also order by created at an ID, which makes me think that comes from an API call, but I'm not totally sure. And we're looking at the top 100 projects by that sort order, basically. And what happens when you run that currently, when it takes like 6, 7, or 8 hours, not hours, seconds, is that it basically performs a sequential scan on projects. That is mostly because of the OR condition. You know, you can't always use an index for OR conditions. Works better for AND, but OR is difficult. And we end up scanning the whole table, evaluating the things on the fly, and we're actually discarding, what's that, 8.5 million projects on the fly. And we still return 1.3, 1.4 million. We sort them, and then we take the top 100. And that is a rather inefficient way of doing that. What we can do about that is, I'll just open that in the issue. I posted it there too. So what we can do about that is actually splitting into different parts. Remember that we wanted to get the private projects, and we can do that in a relatively simple query. So to get the ones that I'm authorized to see, I'll just select the ID for projects where same condition basically as before, but it's only this condition. Like we only look at the ones that I'm authorized to see. And we also exclude the pending deletions. So that's a way to get my private project. And the public ones, in a similar way, we can do basically here, same thing, selecting the ID from projects based on the visibility level as before, same condition for the pending delete, same auto buy, same, and then a limit. I'll talk about that in a second. And then we union those two, right? And you can do without the auto buy and limit on the particular branches, but then you end up like retrieving still very many projects from that union, and then you sort of on the fly order them, and then you take the top 100. And that is not necessary because we only have those two branches for the union. And if you want to make sure that we end up with a maximum of 100 projects, we have to take a maximum of 100 projects from each part of that union, each branch. So what we do is we just take 100 private projects and 100 public ones, and we make sure that the order by is right, because you want to take the most recent ones by created at timestamp and then ID, and we do that in both branches here. So we end up by selecting from the union, we end up with a maximum of 200 projects here, and actually that makes it simple to sort them on the fly. So we would sort them by created at an ID once again, because now we have this common set of like both private and public ones. We sort them again on the fly, and then we take the top 100, but there is only very little data to sort by, so that is quite efficient. We can take that and just, without any additional index, see how the plan would look like. I'll probably have to drop the index I created earlier. This is a lot of columns. Not exactly prepared for that. All right, so this is the query that we just discussed with the union tricks and the push down order by limit clauses. And it still takes a long time to execute. Should probably have put the explain before the query so that we can look at the plan. Do that once again. Now, when we look at this, there is the when you look at this here, this is basically to figure out the projects that are internal and public. So this is the visibility condition. And we basically spend most of the time for this query. So the query took about 2.7 seconds, and we spent 2.5 in actually scanning this index. And we read a lot of data from there. And we have an index for the visibility level here. So that is sufficient to retrieve, but the data we're getting back is quite a lot. And only once we have all that data, we do the sorting. This is here. So the sorting doesn't come from the index, but it's performed on the fly. And then we apply the limit. So we first retrieve all the 1.4 million rows from the index. We do the sorting on the fly, and then we apply the limit and take the top 100 ones, right? And this is actually, I think, the major optimization that we can do here. We can create an index that supports both the condition that we're looking at and the ordering. And the way to do that is creating a partial index for the condition. So this translates to the same condition that we're using in the query: visibility level in 1020, so internal or public, and pending delete is false. This is the partial condition. And now we index columns that directly relate to the columns that we order by. So if we look at the query once again, what we want to order by is the created at timestamp in descending order and the ID in descending order. And now we create an index that has exactly the columns like the order by clause, and matches the sort of the where conditions with its partial condition. And the resulting thing is an index that is a perfect match because it contains exactly the data that you're looking for. And the index order is already in the order that you want to look at it. So basically you can go to the index, you can retrieve the first 100 queries, and you don't have to do any sorting at all. And primarily you don't have to retrieve the full index, right? So you only take the top 100 ones from the index, and that's very efficient to do. So when we run that query once again, hopefully it's very fast, and it actually is, like, goes down to 18 milliseconds. And now when we look at how this changed the plan that's in here, this is the new index that we created. We do an index-only scan, which is also very efficient because we only read from the index. And this is actually what we just talked about. We retrieve the first, that's the first 100 rows from that index. We don't do any sorting on that because we know that reading from that index will give us the expected sort order. We're basically done with that branch, right? And that really makes it a lot faster than before, coming from 2.7 seconds to about 18 milliseconds. So in summary, what we did was fiddling or splitting the OR parts of the query into unions, and then finding a way to make sure that each of those branches only retrieves enough records for us to retrieve the 100 records that we're looking for. And the way to do that was to push down the order by and limit clauses to those individual branches of the union query, and then provide an index for one of them to make sure that retrieving the top 100 by this order becomes very efficient. And by doing that, we were able to speed the query up from, I think initially it was about 7 seconds, about that, down to like 20 milliseconds. And that's quite good. And those tricks are quite universal. So whenever you spot an OR on a query, that may be a good candidate to think about a union with like specialized branches instead of an OR query. And I hope that we find all the places where that query is used. It looks quite familiar. So, I mean, retrieving projects or checking project authorization is something that we do in a lot of places. So hopefully we can find all of them and make sure that we use the better query or the optimized version for that there. I hope that was kind of interesting. I'm always looking for feedback, so feel free to comment somewhere or send me a message on Slack. Thanks.